Hello students, welcome to our channel CS Chemistry. In this video we are going to discuss about the most interesting topic in chemical bonding. It is hybridization. Let's know the definition of hybridization. The process of mixing of suitable atomic orbitals of an atom resulting in the formation of new set of orbitals of equivalent energies and shape. It means the intermixing of atomic orbitals which are having the same energy giving new atomic orbitals. They are called hybrid orbitals, and this phenomenon is called hybridization. The number of intermixing orbitals is equal to the number of hybrid orbitals. Let's write the hybrid orbitals. It is one s orbital combines with one p orbital to form two sp hybrid orbitals. Two sp hybrid orbitals. One s orbital combines with two p orbitals to form three sp2 hybrid orbitals. Like the same wise, one s orbital combines with three p orbitals to form four sp3 hybrid orbitals. Four sp3 hybrid orbitals. One s orbital combines with four 3p orbitals and one d orbital to form sp3 d orbitals. We can count how many intermixing orbitals here. 1, 2, 3, 4, 5. So 5 sp3d hybrid orbitals are formed. Let's find out for 1s. Here 1s orbital combines with 3p orbitals and 2d orbitals to form sp3d2 orbitals. How many orbitals? 1, 2, 3, 4, 5, 6. 6 intermixing orbitals. So 6 hybrid orbitals are formed. sp3d2 hybrid orbital, 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 sp3d2 hybrid orbitals. Here how many are the number of intermixing orbitals? 1, 2, 3, 4, 5, 6. Then how many hybrid orbitals are formed? 1, 2, 3, 4, 5, 6. So the number of intermixing orbitals is equal to the number of hybrid orbitals. We have a small trick to find out the hybridization in molecules for the central atom. That is, trick to find hybridization, that is Z is equal to number of sigma bonds in the molecule plus number of lone pairs on the central atom. Okay, if Z value is 2, then it will be sp hybridization. Its geometry is linear. If Z value is 3, sp2 hybridization having diagonal planar geometry. If Z value is 4, it shows sp3 hybridization having tetrahedral geometry. 5 sp3d hybridization trigonal bipyramidal. If 6 sp3d2 hybridization having octahedral geometry. Let's see some more examples to prove hybridization technique. Let's find out the hybridization for first example, beryllium chloride. Beryllium chloride. First, beryllium chloride. To find hybridization, we have to calculate the number of sigma bonds and the number of lone pairs on central atom. To that, we have to find the total number of electrons. Q is equal to beryllium 2 plus chlorine having the 7 valence electrons. 2 chlorine atoms are here. So 2 into 7, 14. That is 16 electrons in the beryllium chloride. Let's find out bond pair electrons. Bond pair electrons is equal to 2 into number of molecules around the central atom. That is 2 into how many number of atoms? So 2. That is 4 bond pair electrons. Let's find out for lone pair electrons. 16 minus 4. Q minus bond pair electrons is the lone pair value. That is 12 lone pair electrons are present. Let's draw the structure of beryllium chloride. Beryllium chloride. Let's fill the lone pair electrons on the atoms. 2, 4, 6, 8, 10, 12. Let's find the hybridization. Z is equal to number of sigma bonds 1, 2. Number of lone pairs on central atom 0. That is Z is equal to 2. If Z is equal to 2, what will be the hybridization? Sp. Then its geometry will be linear. Its geometry will be linear. Let's find out the hybridization for SO3. Same. We have to count total number of electrons. Sulfur having 6 valence electrons. Oxygen, each oxygen having 6 valence electrons. Here is 3 atoms, so 3 into 6, that is 18. So total number of electrons 24. Here bond pair electrons is equal to 3 into 2, that is 6 electrons. Lone pair electrons are Q minus Bp, that is 24 minus 6. So 18 electrons which are in lone pair. Let's draw the structure. We have to fill 18 electrons on the atoms. 2, 4, 6, 8, 10, 12, 14, 16 and 18. Okay, let's find out the hybridization. That is Z is equal to number of sigma bonds around the sulfur 1, 2, 3. 3 sigma bonds plus number of lone pairs on central atom 0. So the hybridization will be sp2. Its geometry is trigonal planar. Let's find out the hybridization for H2O molecule. Let's find out the total number of electrons. Oxygen having 6 valence electrons, hydrogen 2, that is total 8 electrons are present in H2O. Let's find out the bond pair electrons. Number of atoms surrounding to the central atom 2, that is 2 into 2 is equal to 4 electrons. Let's find out lone pair electrons. Q minus bond pair electrons, that is 8 minus 4 is equal to 2 electrons. That is H2O structure will be number of lone pairs on central atom 4 electrons, that is 2, 4 electrons. That is Z is equal to number of sigma bonds around the central atom 2 plus number of lone pairs around the central atom 2. That is Z is equal to 4. Its hybridization will be sp3. Its geometry tetrahedral. Let's find out some more hybridizations for PCl5. Number of electrons, phosphorus 5 plus chlorine, each chlorine having 7 5s are 35. That is 40 are the total number of electrons in the PCl5. Let's find out bond pair electrons. 5 into 2 10. Lone pair electrons 40 minus 10, that is 30 electrons in lone pairs. That is phosphorus is the central atom, 5 chlorine atoms. Let's fill the 30 electrons on the atoms. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Here also no lone pairs on the central atom. That is Z is equal to number of sigma bonds 1, 2, 3, 4, 5. 5 plus number of lone pairs on central atom 0. That is Z is equal to 5. So the hybridization will be sp3d. Its geometry is trigonal bipyramidal. Let's find out the hybridization for SF6 molecule. The total number of electrons Q is equal to sulfur 6. Each fluorine atom contains 7 electrons, therefore 6 avenge 42. That is 48 are the total number of electrons in the SF6. Bond pair electrons will be 6 into 2, 12 electrons. Lone pair electrons will be 36. When we subtract total electrons to bond pair electrons, let's draw the structure of SF6 molecule. Sulfur, 1 fluorine, 2, 3, 4, 5, 6. Let's fill these 36 electrons in this molecule. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. Okay, let's find out the hybridization. Z is equal to number of sigma bonds 1, 2, 3, 4, 5, 6. Number of lone pairs on central atom 0. That is Z is equal to 6. Then the hybridization will be sp3d2. Its geometry is octahedral. We have another simple trick to find out the hybridization without drawing the structure. It is Z is equal to 1 by 2 into number of valency electrons on central atom plus negative charge in the molecule minus positive charge if in molecules plus number of monovalent atoms. That is fluorine, chlorine, bromine and hydrogen. Let's see some examples for the molecules. First example to H2S. H2S. This is the formula. First, Z is equal to half into number of valence electrons on central atom. Here is central atom is sulfur. Sulfur having valence electrons 6 plus negative charge. Here is no negative charge. Minus positive charge if present. Here is no positive charge in the molecule. Plus number of monovalent atoms. Monovalent atoms, what are they? Fluorine, chlorine, bromine, hydrogen. Here we have a hydrogen. So we have to add the hydrogen atoms. So plus 2. That is 8 by 2. 2 1s are 2 4s. That is 4. So the hybridization will be sp3. Then geometry tetrahedral geometry. Let's find out the hybridization for SF4. SF4. Z is equal to half of the number of valence electrons of sulfur 6 plus negative charge if present. No. Is positive charge is present in this molecule? No. So we have to then add monovalent atom fluorine. How many number of fluorine atoms? 4. That is 6 4 plus 10 by 2. 2 5s. That is 5. Hybridization will be sp3d. Its structure is trigonal bipyramidal. Let's see for xenon fluoride. Z is equal to half into number of valence electrons on xenon 8 plus there is no positive and negative charges, so we have to add fluorine as a monovalent atom. So fluorine atoms are 4. That is 12 by 2. There you get 6. 6 show sp3 d2. Its structure is octahedral. Let's see for SiF4. Z is equal to half into number of valence electrons on silicon 4 plus number of monovalent atoms 4. Here is no positive and negative charges. So 8 by 2. That is 2 4s are 4. If 4 is present, sp3 hybridization. That is geometry will be tetrahedral. Let us see the hybridization for the fifth example. That is CO3 2 minus. Here Z is equal to half into number of valence electron of carbon 4. Here is a negative charge, so we have to add. Plus positive charge is there? No. Number of monovalent atoms 0. That is 6 by 2. That is 3. So the geometry will be sp2 hybridization having the geometry trigonal planar. Let's find out the last example, that is NO3 minus 1. Here is Z is equal to half into number of valency electrons on central atom 5 plus here is a negative charge 1. Number of monovalent atoms 0. So 6 by 2. Here is 3. So the hybridization will be sp2. Geometry will be the trigonal planar. Thanks for the watching.